All right, well, so welcome everybody to this session on Earth data and the cloud and NASA Openscapes. So there's a lot of people that have contributed to parts of this session, all the names up there, and I'll just introduce myself. I'm Danny Kaufman from the Atmospheric Science Data Center of NASA, and we're going to hand it off first to Reese to give us some more of the orienting us all to this session.
Hey everybody, my name is Reese Leahy. I'm a data scientist in Lab 619 at Goddard, Terrestrial Information Systems. Do you want to come?
Hi, I'm Andy Barrett at the National Snow and Ice Data Center, where I split my time between DAC and scientific research.
Do you want to give a shout out? We're here today filling in for Alexis Hunzinger and a few people who will be joining online, but unfortunately we're not able to make it in person. But we wanted to kind of highlight the fact that we're able to jump in here in a really agile way, kind of related to the processes and workflows that we use at Openscapes. So we're going to talk a little bit more about some of the practices we've cultivated in this community, have helped us adapt and be able to kind of jump in last minute and help out in person. So in today's session, we're going to talk about our purpose, the outcomes of the way we work, and some of our processes. And we're going to also get to experience some of those processes in an interactive workshop that we've got as part of this session. So our main purpose is to help scientists and researchers migrate their existing workflows to the cloud to do science in a more collaborative and open access fashion. Some of the outcomes we have from this is there's this wonderful feedback loop where we get to learn from participants what challenges they're facing and then co-design solutions for that, and then constantly be learning their new challenges and iterating on that and creating new solutions. So again, we're going to get to dive into some of those specific processes and participate in that together so everyone can really learn it and try to adapt and incorporate it in your existing workflows. Andy's going to talk a little bit more about that in a second. But in order to participate in this process, we have created a few online resources that should be accessible in a Drive folder with a link that has been sent around already. Yeah, there's a link to it in Schedge, and if you get a chance, please sign up and check in for attendance. So again, yeah, we are Openscapes community. I think, Andy, did you want to jump in here?
Sure, I can.
This is one of the slides.
Yeah.
Yep. Oh, yeah. So Andy's going to talk a little bit more about some of the cloud processes that we work with.
Yeah, so I guess we want to talk about onboarding and fledging. And I'll define those terms later or in a couple of slides. But first of all, why are we here? And really the reason that we Openscapes are here and hopefully why you're here is that NASA's Earthdata cloud is here. And also, other agencies are moving a lot of their data to the cloud. So scientists are needing to transition from old on-prem workflows to cloud-based workflows. So if you don't already know, NASA's Earthdata cloud is its cloud-based archive of Earth observation data. You might have been in the session earlier this morning where we talked a little bit about that. It's hosted by Amazon Web Services in AWS Region US West 2. That's where all the data is going to be. And NASA's currently in the process of migrating all of its data holdings up to the cloud. And the reason, and I'm going to repeat Doug Newman's phrase, the reason that NASA is moving data to the cloud is to make access to data easier and more equitable and democratize science. Those are my kind of added thoughts. So we're needing to refocus data access methods from just the old download and analyze data on either your laptop workstation or even maybe a local HPC facility to doing your data reduction and your analysis in the cloud next to where the data is using elastic compute resources. And this has real advantages. All NASA's data is going to be in the same place. It allows multidisciplinary, multi-mission science. We can provide a common suite of tools to that. And it enables open science. because everyone has access to the data, everyone has access to the same compute environment and the same tools, making more reproducible science. So what we're doing at Openscapes, and Openscapes is a collection of mentors led by Julie Lowndes here, to help people transition their workflows to the cloud. It's a group of mentors drawn from DAX. We co-create tutorials, host cloud training events, practice open science ourselves through our workflows, and hopefully you're going to experience some of the aspects of the way we work as we go through this session today. Open source code, open community software development, and kind of broaden into this kind of large networked open science community. And you can see here that there's a large collection of DAX and other organizations that are involved with Openscapes. It's a community and I guess a social support network. So onboarding and fledging, and maybe we should have called onboarding hatching to fit with the metaphor of fledging. But what we hope to provide with onboarding is give people a friendly first experience in the cloud. When they hatch out of their shells from on-prem workflows, we give them a nice warm nest, hopefully with a few worms to keep them sustained. So teach them about technical infrastructure, lessons in open science and cloud concepts, and provide a supportive social environment where we embrace this idea of we don't all know the answers. Not even the mentors know the answers. We're learning together. Don't be scared. We can work through this. And then once we get people into that state, once we get them comfortable with working in the cloud, we want them to go off and do their own thing, right? Flee the nest, hopefully not plummet to the ground, but take off and fly. So we want them to be able to set up friendly environments in the cloud that work for them, that they understand how to do that, how they're going to pay for it, answer all those questions that they might have, and you might have as you go into this new cloud environment, and hopefully soar high. So I think with that, Julie's gonna talk to you about a little story of fledging.
Great, super, thank you, Andy. We are going to have Alexis Hunzinger from Justice present remotely now. So are you there, Alexis? And maybe you can turn on your camera.
Yeah, I am.
Great.
You might need to mute room 8. I can hear myself echoing. Perfect. Okay, just holler if anything comes up issues-wise. Anyway, hi everyone, I'm Alexis Hunzinger. I am a victim of the rippling effects that CrowdStrike had on the airline industry, which is why I'm not in the room with you all today, sadly. I work at NASA Goddard Earth Sciences Data and Information Services Center. That is just one of NASA's DACs. So I've been working with the other folks that you see here presenting to help people, again, flee the nest. So we're actually starting at the end, so to speak. We wanted to start with an inspirational story of one of our fledglings who came back to tell us about how he's doing. So we're going to share the story of Aaron Morelli. He is a climate researcher at the University of Michigan. He was part of our 2023 cohort of what we call champions. This is that group that we kept in our warm nest and fed them worms and taught them some first things about the cloud. And he actually came back to us just a year later and shared his story with our most recent cohort to, I think, also give them hope and show them that there is a way forward afterwards. So what I will say is I'm just regurgitating one of Aaron's presentations. So you can see his slides, you can watch his recording for the full details here, but I'll just hit the highlights. He found the cloud not to be a place that where you need to fully shift everything over from what you're used to working on and go straight to the cloud. he found the cloud to be more of a superpower, where it's something that's there that you can use when you need it, when the time is right. Um, another thing that he found in the world of cost when it came to the cloud is that it was actually cheaper than he expected. I think cost is very ambiguous and uncertain to a lot of people, and is of course of concern. He did some initial estimation and used a rule of thumb from Matt Rocklin at Coiled to estimate that it's about a dime per terabyte of data processing. So he did an analysis with 150 terabytes and came out of it paying about $15. This was helpful for him because he can now put a number more confidently into grant proposals and know that because he's only going to be using this cloud when it's time to use the superpower, it's a little less than he would expect because he can still rely on resources that he already has at his university in this case. And then finally, the infrastructure, which was set up by folks like us at Openscapes, folks at Coiled, who I know are at ESIP. I'm sure they have presentations you can go watch. Those were places that helped obscure some of those really developer or engineer heavy things that scientists don't really need to worry about. So it was just a more friendly place to be in the infrastructure world. So next slide. Yeah, what makes this a fledging story? Andy had that great analogy about having them in the nest. So this nest is where he got to learn when and how to cloud. That was Aaron's first point. There's a time and a place for using the cloud. It doesn't need to be all the time. He had previously went to like a seminar from AWS that was really geared towards engineers. He had talked with his IT department. He spent an hour listening in both, and it was a little useful, but he didn't really know how to put it into practice. So joining this champions cohort where it's very much user and scientist focused made him more confident that he could use certain tools to get the job done. And then when it comes to infrastructure, again, we provided the Nest, which was in our case, our Jupyter hub that runs in the AWS cloud, as well as Coiled, which was something that Openscapes provided as another way to dip your toes in the water and see what it's like to have some of that kind of nasty AWS stuff obscured for someone who doesn't care about that part. They just want to get a result and get their research out and move on in the science world. And then finally, once he did some tweaking and some prototyping in those experimental spaces, he was able to then, with the support of his university pretty critically, use that funding, use that resource that Coiled provides to do his real science and get his result. So this is a moment to pause and say, this is a huge deal. This fledgling story took a lot to get here. So it's been 10 years of NASA engineering teams getting data into the cloud. It's already been 3 years of us folks that work at the DAX helping, not only helping users learn, helping each other learn about the cloud, reiterating when we learn something new, either from our engineers or from our users. And then it's taken curiosity, commitment, as well as trust from our early adopters who were brave enough to just get in the nest and learn about the cloud, as well as those who are trying to fly right now. So Aaron, this is a great template that he's made, a trail for others to follow. We're really excited to hear of others and their successes. We would like to keep in touch and continue to check in with our past participants. And we recently sent out a survey that was just seeing if folks are still using the cloud, in what capacity that they're using it, and what challenges that they still encounter. So my plug is that on Wednesday at the poster session, the details of that survey will be on that poster. I won't be there. My colleague Chris Batisto will be there to interact with you all. So that was our fledging story. I went over a ton of things in there that it's everything it took to get there. So that's what the rest of this session is about, is to go into more details of the how we got folks to fly. So I'll turn it over to a different Aaron Freeze, to talk about NASA Openscapes and how we work.
Thanks so much, Alexis.
So my name is Aaron Freeze. We're going to kind of sprint through a few of these slides just to get to kind of where we want to be. I'm going to talk about how we've worked as an Openscapes group. What do we do? Arrows don't work?
Maybe you have
Not
to click back
sprinting.
into it. Click back into it. Oh, no.
There we go. All right, so we're essentially a team of multi-DAC scientists and developers, and technologists who are working openly with collaborative tools and open software, really to kind of push or teach others how to move to the cloud. Ourselves, we didn't come into this experts in that, and so we've had to also kind of teach ourselves and be kind of open to that experience. We've created a kind of a safe space for this type of activity where, I mean, you don't have to be really worried about asking questions, and feedback is encouraged. And so it's really kind of coming in with just the best intentions to help build out the community. How this kind of played out for us is we kind of start with this smaller mentor group, again, cross DAC, across multiple DACs. We kind of bring our expertise, bring our lessons learned, and try to teach them across the group. Those then lessons and tutorials, resources are then brought back to the DACs and kind of distributed in, not really distributed, but made available. We want to make stuff kind of once, use it multiple times, or reuse it many times. And then take that experience and then bring that to our end users, or at least bring our end users into our safe space so that we can kind of guide them and help them learn how to move to the cloud. We're doing this all in the open using open science tools. And so we do our best to try to contribute back and either trying to build out or report issues, or even contributing new tools like Earth Access to the community. Any day of the week, you'll probably see something like this where we have conversations with people from multiple DACs testing either a package or testing some technology that is just getting some feedback from multiple people at any time. We use GitHub quite a bit, so we can do asynchronous contributions where all of our resources are kind of controlled through GitHub PRs. So anything that kind of gets checked in goes through somewhat of a review, and any comments can be made toward those. And then we started using this GitHub for project management. We use this kind of to identify opportunities for collaborations or just keep track of deadlines and see where each of us DACs may be going to see if there's potential for collaboration. And so we keep that up to date. Essentially, we have a team. We've created an environment that really kind of has developed habits and created a community that is empathetic and is supportive of each other. And we've tried to take that not only back to our DACs, but also within the communities that we represent as well. I think one of the best things about really any member of the Openscapes group is that we do have this kind of growth mindset, that we don't know everything, that there may be somebody in the group that knows the answer to our question, and we often bring it up and it's often discussed, and there's really no embarrassment in that. One of our early milestones was this Cloud Hackathon, where we leveraged the open source tools, GitHub, and used some newer technologies, 2I2C and Quarto, and really kind of created multiple resources and a space for our users to come in and just really learn about data access and search in multiple use cases. Ultimately, it was a very successful event, and really this kind of catapulted multiple workshops that I think you'll see workshops later on, but there's actually probably dozens more that we've actually supported using this space. And so another kind of important part of our kind of mission is this Openscapes Champions group, where we spend time with researchers who have problems and come into this space to kind of figure out how to get past those problems. We spend time with them for about a couple months at a time. We continue to support them as needed going forward. And so these have ultimately kind of led to kind of, I'd say, breakthroughs like Earth Access into I2C and others. So I think that's it, and I'll hand off to Danny.
All right. Thanks, Aaron. Actually, we were going to, at this point, put up a Slido, like some questions, but we're running just a few minutes behind. So if you're interested in just answering a couple of questions and seeing what we were interested in polling you all on, you can go to the notes document through Schedge, and there's a link there. If not, no worries. Okay, now we talked about sort of how Openscapes sort of functions. We talked about why we're here in general, and now we're going to talk a bit more in depth about the onboarding part of it. So for onboarding, as Andy mentioned at the beginning, this is really that aimed at getting those friendly first experiences in the cloud. So oops, I'm going to do that real quick. Okay, so yeah. So to get to that friendly first experience in the cloud, Openscapes sort of curates and tries to provide a number of different resources through 3 different lenses: through the technology side of things, through the people, and then overarching all of that are some of the rules of use for, and this sort of underpins all of the interactions that we have, whether it is the tooling or whether it is the people side of things. So when Aaron was mentioning about the Cloud Hackathon and mentioning about the Champions cohort, you could think of those more as like the people side of things, and then the infrastructure in the cloud that we're providing to folks, that's maybe more the technology side of things, and so on. So this is sort of a diagram here of what people are trying to do. So if I'm not going to go through each step here, but just in general, finding data in the cloud, and then in order to utilize the cloud, there's going to be some step where you have to set up a space in the cloud. Ideally, if you're doing things openly, you would set up this co-development space so you could collaborate with other folks as well. Authentication to whatever data providers, and then actually getting the data and analyzing it. And Openscapes is really trying to provide all of those lenses of support at various parts along that way, not just in one place, but learning from the users and from ourselves as we try to use things, and figuring out what kinds of tools can we apply to make this more streamlined, what kinds of social interactions do we need to have to make it easier for folks to learn. So Aaron already mentioned the Champions program that provides this direct mentorship for several weeks, where we interact directly with folks that are trying to and interested in learning about how to migrate workflows to the cloud. And then these workshops and events. Aaron mentioned the Cloud Hackathon in 2021. I've listed a few others here just as sort of a taste of some of the things that we support. So workshops, other hackathons, events, this session, to kind of reach into various different user communities across different data centers. You'll notice a couple different data centers here. So LPDAC, the Land Processes DAC, then the AGU community, SWAT, and one of the mission-focused ones, and so on. In addition to those, the Champions program and the workshops, another place that's, this really is both tools and people and rules of use, is this cloud cookbook that Openscapes has developed and continues to iterate on in the open. It looks sort of like this. On the right-hand side, you see a screenshot from it. This is a collection of various tutorials that we've used and developed for those workshops and hackathons. And then we incorporate all of the feedback and improve the tutorials as we go. And even the folks in the workshop could also contribute to it because all of this is on GitHub. And importantly, this is the steps and guidance that's provided through the cookbook is common to the various data centers. It's really focused, again, in the top right corner, this Earthdata cloud. That's why we're here. So you can see on this in the screenshot, you can see the kind of on the sidebar where there's links to cheat sheets to make people realize how easy it is to kind of get a view of how to get started in the cloud, and then the various tutorials. And some of the tutorials will look like this, where this was for an Earthdata Cloud Clinic. And this would just be sort of from the Cloud Cookbook and seeing how we would introduce topics like Earth Access or Harmony Pi, talk about it in relationship to missions, into specific topical questions that people would specifically have. Okay, so that was the cookbook tutorial. Now, I would say that's both the people and the tools, because we have something on GitHub and it gives guidance on using tools, but it's developed in this interactive way with people during these events. Jupyter Hub is also kind of tools and people. It's the cloud infrastructure that enables us to do those workshops and to give guidance. And it's really, this was someone else's idea to show it in this way, but the Jupyter Hub is sort of a way to go from one workflow to another. So this is the first workflow where somebody gets a cup of coffee, they try to find what kind of data they want to access, they go to the provider's website, and oh, it only works in Chrome, they don't have Chrome, or okay, so now we need to switch browsers. Then they have to click around, going from link to link, trying to find the exact data that they want. And once they get to it, then next time they're going to have to do the exact same thing again. It's not very reproducible. And then finally, they download and analyze the data using GIS tools. Of course, that might not work if the data are too big. Maybe you have to compile some code. That can be quite a headache. And you end up with this rabbit in the corner getting rained on with a small cloud. And then the other workflow is where you get a cup of coffee and then you go to the Openscapes Jupyter Hub, which is Openscapes 2I2C. It's provided some of the underlying infrastructure provided by 2I2C. You don't have to install anything. It's a complete environment to run a workflow, and there you are, you're doing science. So we're trying to get to that second workflow. That's going to be that safe nest that people get their first experience in the cloud, is this more friendly space. It's language agnostic to some degree. You can run Python on it, you can run R, you can run MATLAB, or you could also even, if you're so inclined, build your own image in Docker and run that in the Jupyter Hub as well. Some of the benefits of this is it interfaces with GitHub, so it's not even setting up really a new credentials. You just can use GitHub credentials. Sessions persist. You can store things and come back to them weeks later. It's in US West 2, the same place that the NASA Earthdata Cloud is, which is awesome when you're trying to run really fast computation, reproducible kind of environment, and so on. There's this will come back later when we talk a bit more about the fledging part, but this is sort of a model for how to set up cloud workspaces in a reproducible way. There's I'm not going to go through each part of here, but there's a continuous integration pipeline that builds these different environments, the different kernels. The base image is called corn for the kernels. And if the particular versions and libraries aren't included, like we said before, you can bring your own environment. There's GitHub Actions to automate the process of building new base images if there are changes to the configuration files, and ultimately that is then deployed, and it takes maybe a couple of minutes, depending on what you're trying to do. Okay, so that's Jupyter Hub. Again, a tool, a technology, but we are involved intimately with the people side of it as well when we're deploying this Jupyter Hub and getting people familiar with it in the context of the workshops and the hackathons and sessions like this. Finally, Earth Access. This is an awesome example of Openscapes recognizing the needs of the users during those events and seeing a way to make it easier to do that cloud workflow. So recognizing that one of the really challenging parts was actually authenticating and then finding data for if someone who wants to do things programmatically. So Earth Access provides a bridge between all of the NASA data centers that provide the data, and then all of the kind of ecosystem of tools that folks want to use on the data. It makes code that might be 20 lines long or more that would have had to provide credentials, do session handling, remember the credentials, and then figure out how to talk with the metadata repository for NASA. And it takes all of that and puts it into 3 lines of Python code. And this has been a huge success, widely used across the DAX, both internally and for external users. Okay, so those are kind of the main things that I wanted to highlight. And just to, again, reiterate the part of underpinning all of this is also to make the people side of it and the technology side of this really work and make everyone know the expectations so that the expectations aren't misunderstood. Or there are details about this Champions program on the Openscapes website. There's policies that we've kind of, again, iteratively defined how an effective way for people to access and then utilize the Jupyter Hub. Policies on data retention for using the Jupyter Hub. And then finally, the license that is defining the acceptable use of all of these materials that makes it all wide open. Okay, so that is it for that section on kind of the Openscapes tools and how we onboard. So now I'm going to hand it over to Julie to talk now about the next part of it, going from the nest to the fledging.
Great, thanks so much, Danny. I'm Julie Lowndes, and it is so exciting to hear all of this. And when we talk about Openscapes doing things, it is this open source community across the DAX and beyond that are doing this. So I think that's so exciting to see this, like the we of this movement. So I lead Openscapes and the NASA Openscapes effort. And together with my colleague from NOAA Fisheries, Eli Holmes, we're going to give some examples of this early fledging and where we are. And this will kind of help us kick off to the breakout sessions we'll have following this, where we'll be able to talk more and hear from all of you about your questions and experiences as well. So first of all, fledging, we're really asking this question of where do researchers go when they decide to do their science in the cloud? And as like a little historical aside, we did used to call fledging offboarding, but we really wanted to center the user. Like, what does the user need to do? We're not trying to offboard them off the tech and have them have a cliff. We really want that idea that they can soar. So how do we enable that? So there are fledging questions for us, and when we think about fledging, and as we go forward with all this, we really want to think about equity in fledging. Is fledging different for different communities? What do we need to do to support, and what can we do? But really, there's policy questions. How much does it cost? How do I pay for it if you're a user? There's tech. There's at least 3 tiers, but we're curious to see how you think about the tech. First of all, where do people go? Do they go to another hub? Do they go to Coil? Do they go to Colab or Google? Where do they go? AWS was 2. What admin setup do they need in terms of Jupyter or RStudio or MATLAB or ArcGIS? What science setup do they need in terms of environments, base images, like corn, as Danny just talked about? And then also the social side. How do I learn this stuff? How do I support others and advocate for this in terms of my organization? So when we talk about the NASA Openscapes 2I2C Hub, we've been communicating about fledging early. So this is written as part of our policy that the purpose of this Jupyter Hub is to provide initial exploratory experiences to access Earth data on the cloud. It is not meant to be a long-term solution to support ongoing science or software development. So we've always communicated that that fledging was going to come along. But to date, we haven't removed folks from our Jupyter Hub because we don't have a place for them to go. But we have set up the tech and policy setup to do so. So we have 4 tiers of users that we organize in terms of long-term access, which are the NASA Openscapes mentors and collaborators. We have the champions cohorts participants who we work with in the nest for longer with those worms like Alexis was talking about. We plan that they'll stay for a year. Then we also have different workshops and hackathons, and we expect that those folks will stay for another 3 months as they explore. And then we've also just recently collaborated more closely with 2I2C to have short-term workshops where they use a shared password like you would share a Zoom link. So we have about 400 users in the hub right now, and we have not yet fledged them, but we're set up to do so. I wanted to call it specifically UV Panda and Aaron Robinson for really setting this up. So the next question is, how much does it cost when folks fledge? So we deliberately delay this question. This is not part of our onboarding. This is part of our fledging. We really want onboarding to focus on scientists experimenting about when to cloud, when does it make sense for the cloud to be right for them. But when they're starting to fledge, cost is important. So this is a snapshot from this year so far, looking at our costs in our hub. So June was $1,289, and you can see in the bottom, it's broken down by different uses of our hub. And what we're starting to do is have monthly usage reports that we will post on GitHub for us to not only see these costs, but then to start to annotate them. So this annotation for June might say that the total cost was that $1,289 for all the users, all those 400 users in our hub. And that was kind of stable for the last couple months during that champions cohort we had. March was high, and that was expected because we had large instances from one of LPDAC's emits workshop that supported users in the cloud. And then if we start to annotate the bottom colored graph, we can say that the EC2 compute costs, which was in red, in May was slightly higher from a different LPDAC workshop, but that the storage costs in green really reduced over time because we actively cleaned up storage and started to teach users how to have shorter storage, more effective storage. So when people ask how much does it cost, we're starting to have better starting numbers for folks. So Aaron Morelli, as we started off with his story at the beginning, had $15 for his AGU poster and estimated that it'd be a couple $100 per year for grant proposals. But that is under the exception that code is efficient and data storage is efficient. So those are things he had to learn and do. So that's a big opportunity for us to teach. And then there's also admin costs for the infrastructure. So these are some starting numbers around the cloud credits that we've had in support of the NASA and AWS collaboration around the Space Act Agreement. Additionally, with the 2I2C annual costs for infrastructure management, and then also people's time. Luis Lopez, Aaron Robinson, myself, Andy Tusher, UV Panda put a lot of time into managing our hub. So as I hand off to Eli Holmes, who's gonna take it over in one moment, and you're welcome to come up, some ongoing fledging questions is, as we continue to think about equity about different communities, is how much does it cost per user? We're starting to be able to see per user usage, both through Coiled and then also in those monthly reports based on our user groups that I mentioned, those 4 categories. So we'll be exploring and able to communicate with users as they have big storage and what we can learn from that, or big compute and how to reduce. But we also have tech and social questions. One question on my mind is how to elevate and amplify corn, that Docker base image, as an open source community activity following the path that Earth Access has done with the NASA Openscapes community. So Eli Holmes is going to be able to talk about this more from both a researcher and a sort of admin person perspective. So Eli, welcome.
Hi, everyone. I am Eli Holmes from NOAA Fisheries, and I'm going to give you another individual fledging story, my own fledging story. I was an early participant in the NASA Openscapes activities. I participated in the November 2021 Cloud Hackathon. At that time, I was still in my old career, which is as a research scientist. And that was my first introduction to Jupyter Hubs. And I was like, oh, wow, this is fantastic. I was also new to Python. So for me to be able to drop right into this environment, all set up to do cool science, I worked on a project related to coastal upwelling. I really was like, wow, this is the way. And after that, I went home. I'd also done a lot of teaching, done lots of workshops, so I was very familiar with the pain involved in trying to get things set up for users on their own computers to run events. So I went home and I immediately started learning about Jupyter Hubs. I think a week later, I set up my first, the littlest Jupyter Hub. And then after a while, I was able to recreate the Openscapes Jupyter Hub on Kubernetes, doing that on Azure. And then the next a couple years ago, started using, setting these up for teams. If that's something you are interested in, I keep notes to help other people learn how to do that. And that first event also led to a career pivot. Like I said, I've always been involved in like teaching workshops and teaching, but after being involved with NASA Openscapes and involved in some of their activities at my line office, NOAA Fisheries, and also the COVID times, I made a big career pivot and decided I would move into a leadership position in my line office to help lead the adoption of open science, open data, open collaboration across my office. I'm not the only person involved with this. This is a real big effort. In fact, all the federal agencies are involved in this. My focus is on helping staff, particularly the scientific staff, adopt new analysis workflows, in part cloud, but not just cloud, but adopting new workflows based on reproducible environments. And I'm going to talk about one little aspect, kind of a tech aspect of something that I do. Most of what I do is working on big working groups and doing a lot of like governance stuff and coordinating things, but I also work on some technical things. So one of the barriers that staff face to adopting reproducible workflows in new environments is the problem that they need to install, or they need to have tech IT. And in fact, if you're at a federal agency, it's not like you have admin access to your computer. They need people to set up the whole environment. And that is actually really hard. And it's really hard, especially when we have to set up complex environments that are really kind of persnickety, how you set them up. And people have different, computers, different things installed on them. This is really hard. And the amount of time that we have, across, you look at a center, amount of expertise and time they have to help with that setup. I call those the misery hours. That's a finite resource. It is not an infinite resource. It's just not. And it has real impacts on what people can do. So it means that most people can set up easy environments. Yeah, you just need to install something and you just got the basics. So kind of lots of people can do that. But if it's a hard environment, it's going to require some expertise. It's the reality. Few people are going to successfully get that set up. Moving towards a containerization mindset, and Julie showed at the end this corn environment. That's a container, an environment that you can take that image and you can run it lots of different places. That kind of mindset breaks that whole graph right there, because now you've created something. No, it wasn't easy to create. Yes, there's lots of misery. I developed these things. There's a lot of misery. But you do it once and then hundreds of thousands of people can use it. So this is one of the things that I've been involved with. I'm involved with this with a number of the NASA Openscapes mentors, and it's taking something called PyRocket. So they have corn, that's their Python environment, but also have this other image called PyRocket that Luis Lopez developed, and then Carl Bettiger and I took that and we kind of ran with it, and it creates something that combines like Pangeo and Rocker, so it's real comfortable for both the Python user and the R user. And then what I've been working on is altering that, creating some scaffolding so that you can just run it out of the box in lots of settings. Not everybody is going to have a Jupyter Hub, but we want an image that runs really seamlessly, like with Docker Run, but also like in code spaces. So now I have a version. If you have code spaces, it's free. You do click a button and you're in an environment that looks just like the Openscapes Jupyter Hub. So got that going. And now I'm working with Google Cloud Workstations. That one's harder. And my last message is this: when you're thinking about fledging, we're up here in this nest, this nice nest way up high in the Jupyter Hub with Openscapes, and it's easy to think about the people who need to fledge are only birds, and you only think about the bird needs. But some of those people are zebras. Zebras have very different needs if they need to get from that nest down. And then the fish have even different needs. So remember that it's not all birds up in that nest.
Awesome. Well, thank you, Eli, as well. We're really excited to get your ideas now and have a discussion. So we're going to take a moment and ask you to fill out this Slido poll as to help us break into breakout rooms around the room. So this is a QR code here on the screen, and it's also linked from our Google Doc if you're following along. And we just have a few questions, and I'll give you a moment to get there and answer the questions, and then I'll show the results of it, and then we'll get to stand up and talk together more. Anybody want to sing? Do we have some music or? Yeah. Great. 20 folks responding. Yes, thank you. How about you? I'll leave the QR code for a moment, but then after I show this, I'll just No, it's great. It is great. It is great. And I'll just start showing the results here just to start the conversation. So we asked, are you a cloud user, a cloud enabler, facilitator, or neither? And we've got a good mix in the room, more enabler facilitators at the moment, but a great mix. What triggered your interest in the cloud? Mission requirements, large incoming data sets, and seeking efficiencies and compute power are the main ones at the moment. Super cool to see these change as more people are here. I see 47 responses at the moment. What cloud do you use? This is cool. A lot of diversity, some name specificity. AWS, Google, Array Lake, Azure, GCP. And then what are you most interested in learning about next? How to support others using it. That is awesome. I'm glad you're here. That's really, really cool. How to pay for it also is a big question. And then there's some open responses as well, how to make it not more accessible to non-cloud engineers and developers. Great. Yep. What use resources, crowd terminology. Great. Well, please continue filling that out, and we'll have a chance to reconvene at the end. But Danny will give us our next steps right now.
Is the slide still here? Where is it? Oh, okay, great. I'm gonna flip all the way back. Yeah, okay. All right, so yeah, now we're gonna actually do some interaction. Sorry. We're gonna do some breakouts so that way we can actually achieve some of the outcomes that we're really hoping for here. So if I brought back up the outcome, this slide from the beginning here. So some of the outcomes that we put down here was to Openscapes is really interested in learning from you guys because you guys have lots of other ideas that we haven't yet thought of. And then the second one there, co-design solutions. So more minds are most of the time better than fewer. We wanted to invite you guys to contribute. So this is a way to kind of see how we work and how we really make every effort in everything that we do to be inclusive, interactive, and invite everyone's ideas. And then the last thing here is we are thinking of afterwards we're planning to publish a blog post that summarizes some of the ideas that are brought up here with regards to both onboarding and fledging. Okay, so those were the outcomes. So I'm going to flip all the way back here in the slide deck to some brief in guidance here. So this part, we really wanted to talk with you all and for everyone to talk with each other about questions like how do you onboard and fledge? What do your user needs? That's if you're either a cloud user or a cloud enabler. Yeah, so actually, Andy, or I'll just mention. Yeah, so basically the instructions are here is to think about stories. Think about if you have gone through processes of yourself and have experiences that stick in your head about onboarding and or fledging, kind of having your first experiences trying things in the cloud or setting up more complex workflows in the cloud. Challenges you encountered that either you overcame or ones that just that were roadblocks, and then even if you haven't kind of gone through any onboarding or fledging yourself, what questions do you have in your head? So we have ways to do this in person and online. For everyone in the room, there's 4 pairs of poster boards on the walls. There will be 6. Oh, there will be 6. Okay, awesome. Yeah, because actually there's plenty of people. So the posters are divided up into onboarding and then fledging. So we're going to break out into groups, and you can either write or stickies. Actually, we have better instructions. Online, there is a slide deck in the same deck that's linked to from the Sketch website and in the notes document that has slide decks that we'll be adding to. So we're going to do that for, what is it, 20 minutes? I think 20 minutes we have set aside to do this collaborative brainstorming activity. And let me bring up the slide deck here. Somewhere here, breakout slides. Okay, so we were hoping to aim for like a 4 to 5 person group each. I think it'd probably be simplest if whatever quadrant of the room you're in to kind of go towards the nearest poster board. And I'll say break in a minute, but basically you find the 2 slides, you can either add bullets with the pens or markers that are next to them, or you could just write it onto sticky notes and add it into the technology column or the policy column or the social column. And for inspiration, we have this haiku, which is to to talk about the social, the technology, and the policy. Andy.
Am I going to read it?
Yeah, please
right.
read it.
I think
in your most soothing voice.
Okay. Are you sitting comfortably? I shall begin. In crowds, insights bloom. Tech whispers secrets anew. Policy guides true.
Break. Okay, so yeah, get up, move to the nearest poster board, and thoughts that you have yourself, or if you want to talk about it with somebody that you're sitting next to, and then we'll come back in 20 minutes. Oh, and for those online, if you need extra, you can go to whichever breakout room you would like, and if you need more, you can add more slides and duplicate them.
All right, everybody. So you're welcome to take a seat. We're going to do a report out in a slightly different way than traditionally. I'm so excited about the conversations you've all had. The way we're going to do kind of this reconvene, recap, and discuss is something that Charlie Haley designed with us from ESIP. We're going to do this popcorn style. So we're going to ask, starting with onboarding in the technical category, if there's something that stood out to you from your breakout group, could you raise your hand and you'll share it? And then we'll get a raise of hands, like +1s, if other people heard that. And then we'll ask for another one that we haven't heard yet and kind of get a sense of the conversations in the room. So we'll go down this list here, kind of set up as the way the poster boards were, onboarding with the tech focus first, if anybody would like to kick us off.
Support for legacy code, in fact.
Okay, so then you can raise your hand if you also have the support for legacy code, like bingo, like, or you could yell +1. Okay, so support for legacy code being like a challenge, I'm assuming. Yeah, great, awesome. Thank you, Aaron, for giving one. So anybody else can just shout out something. Yeah, go for it, and I'll repeat it so that way the folks online can hear as well. And anybody online could also unmute and shout something.
Lack of understanding of what is available before onboarding, and what can and you can't do.
Okay, great. So that was, yeah, well, actually, Julie's writing it so those online can see it, but the lack of understanding of what's available before onboarding, and so not knowing what might be possible. +1s? Awesome. I'm seeing like 15. I think. I did bird counting once for one summer, so this is sort of like that, I feel like. Okay, so somebody else shout something out. Yeah.
So the first one is you're not able to pick up the hood and do QA, QC, or data cleaning.
Not being able to pick up the hood and do QA, QC, and data cleaning. Yeah, okay, another challenge.
And then my second one is companies can decide to change their products, they can get bought, they can discontinue whole departments. What happens then?
Okay, so another potential challenge, but not being able to or if companies change and not support their products or other things. Okay, +1s? Did that come up? Okay, I see just a couple. But yeah, that's great. Thanks for sharing those. All right, somebody else want to, you don't have to shout. You could actually speak in a normal voice if you want that too.
For policy, contribution guides, licenses, code of conduct, we're working with the community, and also migration policies for after your event is done.
Great. So do we remember, was that listed as more of like the challenge side of things, or were those questions?
Challenge.
The challenge. Okay, so the challenge of having contribution guides and migration policies, getting image and data off of, I guess this is into the fledging side of things. So once you're setting up something new. Great, so +1s that come up on other boards as well? I see a couple. Great, thank you. All right, someone else want to add one? Go for it.
Well, we had a challenge, technology challenge of having to work with both cloud-based and on-prem data.
Okay, a challenge for the technical side, I guess,
Right.
working with both on-prem and cloud-hosted data.
It's not everything can be cloud-based.
Yeah, okay. Not everything is necessarily cloud-based, so having to deal with both at the same time. Other +1s, yeah. A good bunch. Awesome. Maybe 20, 25 +1s? I don't see any bird behavior though, just bird counting. Okay, yeah, another one.
On the social side, it's important to really build trust
Uh-huh.
into the technology for all people to actually accept it.
Okay, so this is also a challenge. Again. Yeah, so the challenge of kind of building trust and having folks accept that this will be a good way to do things. Great, thanks. +1s?
Maybe part of that is being friendly to people with, who are not already Python or people, like being nice to MATLAB people,
Ah, yes. So the follow-up was it being nice to other folks besides the Python folks and possibly R and any other language. Another challenge. Oh, did that come up also, +1s on that? As well, the multi-language, different languages? Okay, I see half a dozen. All right, someone else want to add one?
I'd say that on the social side, a challenge is ensuring we educate and also like ourselves can reimagine our workflows to be more cloud friendly, because it can be pretty costly to continue working the same way that we have in terms of data storage and access and producing data.
Great, thank you. +1s? All right, I'm seeing about another like half dozen. Thanks for adding that in. Yeah. Okay, so maybe now more on the fledging side, specifically fledging. Were there things that you wanted that really stuck out that seemed really relevant or highlights? I see a hand. Yeah.
On the technology, like security IAM policies can be restricted to do R&D.
Restrictive security policies that make it harder to do R&D was the challenge for technology with fledging. Yeah, +1s. Okay, yeah, that's like a dozen or 15. Thanks. Yeah, cool. Okay, other fledging points that people.
knowing where to go after you finish your introduction to training, where do I build my next structure?
Okay, so on the technology side, so like, yeah, so where does one go? What technology can one use after getting familiar with some to build the next cloud system, cloud structure? +1s, yeah. +1s. I see a couple on that one. Thank you.
Also on the technology side, either like things like coil or things like coil that don't force you to actually run a hub, but still be able to scale horizontally and run your cloud workflows are amazing for your users, right? Like anybody can just do it without any kind of IT, it's incredible, right?
Yeah.
So I think that's a huge piece because otherwise stuff might be done and all that stuff.
Great, yeah, so this is not a challenge, but like a story. This is like the experience of,
As you demonstrated in your talks.
yeah. Yes, so this was about the coiled and things like coiled being providing such a great way for people to get started without having to have an IT department help them set up an environment. And yeah, awesome. Did that come up on the other boards as well, plus ones? Okay, that one didn't come up on other boards, but it doesn't mean it isn't a great idea, a great suggestion or.
Yeah, I think I'm gonna do an unconference, I think on, if you wanna try out coiled on the ESIP.
Oh, awesome.
Then I think we'll do that.
Oh, that's awesome. Yeah, thanks, Rich.
Come check that.
Yeah, so they're probably going to be doing an unconference on coiled to kind of.
I don't work for coiled.
Okay. An unaffiliated, unofficial unconference
Blessing Manny Burgess.
to work through coiled and see how it works. That'd be great. Thanks, Rich. All right. Did questions come up? I guess I didn't see too many questions being shared, but questions?
Let's start from the group back here. There was a pledging, if you have a mature use case, but do you have a grant, do you have the support to actually move forward with that?
Okay, great. So this was on the fledging side of things, and the question was about like, okay, you might have a great use case, but do you have a grant? Do you have some sort of financial support, organizational support to actually make the fledging happen? Great question. Did that come up on other boards as well? Yep, I see a couple. Yeah, thanks. Okay, well, I think, oh, yeah, last one.
Board, but I want to throw in that's important. Mistakes in the cloud can be really expensive. I think when you're working on an HPC, the worst thing you can do is get an angry email from your HPC staff. If you make a mistake on the cloud like that, you could be out a couple hundred, couple grand very easily.
Yeah. Okay, so the point was brought up that mistakes in the cloud can be very expensive, very quickly, depending on what you do. Yeah, thanks for sharing that. Did that come up on other boards as well? Yeah, a handful of other boards as well. Okay, so in the interest of time, I think we probably, Julie, I think we probably need to kind of a quick closing. And we didn't have as many folks sharing online, but that's not to say that we didn't really value everything you shared as well. And this, like I mentioned kind of at the beginning, this is going to go into a blog post. And so we'll have all of the contributions and questions, kind of try to wrap those in if you're interested in contributing. Okay, Julie.
Thank you, everybody. This has been such a successful, interesting session, and we're really appreciative of you all being here. So thank you from all of us, from the whole team here, that's not here, that's online. We all contribute to making this possible. We wanted to share three takeaways from the session here. So they're joyful takeaways. The first is biggest shared challenge is working with on-prem and cloud archive data together. That's something that we've kind of heard collectively through the session. Create early experiences for folks through hack days, through screen sharing with your colleagues, watching videos so that we can feel and see what's part of the cloud and share those stories and get those experiences. And then also the community is critical, really building trust, learning from each other, connecting, reusing what works. So we wanted to invite you, this is the very beginning of ESIP. We're excited to keep talking to you, keep seeing you, coming to your sessions. We've got other sessions, but please talk to any of us at any point. There's some poster sessions specifically with Alexis Hunzinger and Chris Battisto, as well as with Eli Holmes. So those are great places to come and learn more about fledging challenges and successes. We will draft a blog post and reach out to folks that said they wanted to continue contributing through the roll call up at the top of this doc. So please feel free to come back to that and add your name if you'd like to be a named contributor to the blog post, but we'll kind of summarize what we've learned and take the Post-its and everything. We also end each of our Openscapes sessions with an efficiency tip and an inclusion tip. These are often tech-based when we're remote and thinking about cloud or computing, but we thought here together we could reimagine them. So our efficiency tip is that there's a great brewery recommended by Andy Barrett called the Green Man Brewing. And we're gonna go there after the reception tonight for dinner and hanging out. So if we want to keep talking about efficiencies and plans for NASA Earthdata in the cloud, please join us. And then an inclusion tip for a conference is the Pac-Man rule, which is when you're chatting in informal conversations throughout the week, instead of standing in a closed circle with folks, orient your posture to make a mouth like Pac-Man so that someone else can join. And this also gives folks a way to just join a random conversation by saying, can I Pac-Man here? And it's great. So, sorry? Make the shape of, like, instead of a closed circle of 4 people, you kind of, there's a visual if you click on the links, but the idea is to just welcome folks to conversations with your body posture. Great, thanks everybody.
Thank you.